Hello and welcome to Edusathi's lecture on set theory and Venn diagrams. Now, this is a very interesting topic and also a very scoring one. I hope you'll enjoy this lecture. So let's begin. The first thing we address is what is set theory. The study of a collection of objects is called set theory. We'll look at a few definitions first. What is a set? A set is a well-defined collection of objects. Everything in the universe can be represented in the form of a set or a subset. For example, a set of vowels would be A, E, I, O and U. A set of natural numbers would be starting from 1 going till infinity. Then we can have a set of intelligent students. So basically anything can be represented in the form of a set. Now what is a subset? Now, this set of vowels is a subset of a set of alphabets. So, if I have a set of alphabets here, I will have starting from A, B and ending at Z. Now, this set of vowels has been taken out from this set. So, that is why it is called a subset of the set of alphabets. So, a subset is basically a smaller set taken out of a bigger set. What is union of sets? Collection of all those objects which are in either of the sets. For example, a union of two sets A and B, which is represented as A and this union sign B, is a collection of all those which are in either A or B. All those objects which are either in A or B. For example, let's take a set A, a set of vowels here. So I have A, E, I, O, U as set A. Then I have a set B, a set of natural numbers 1, 2, 3 and 4. Now if I add both these sets or take a union, then I'll get a figure like this, which would be a set of vowels and natural numbers. So I have a set which combines both of them. This is called union of sets. So you basically just add the elements in both the sets. Let's look at intersection of sets. Collection of all those objects which are common in the sets is called intersection. It is represented as A, this inverted U sign, and B. Now graphically, if I have a set A as shown here and then I have a set B, so this is set A and this is set B. Now this is the region which is common to both the sets, so this is represented as A intersection B. In other words, let's take a set of alphabets. Then the set of alphabets is A, B and so on till Z. Now let's take a set of vowels again. I have A, E, I, O and U. Now if this set is set A and this set is set B, then A intersection B would be the elements common in both the sets A and B, which would be nothing but the set of vowels A, E, I, O and U. So this means that these elements are common in this set B and this set A. I hope you are through with this. Now we look at some of the symbols used. A means all elements of the set A, which is 1, 2 and 3. Here I have defined set A as 1, 2 and 3, set B as 2, 3 and 4 and set C as 2 and 5. We look at all the concepts we've done till now. So this symbol A and a line on top is called complement of A. Now what does complement of A mean? It means all elements except set A. So if this rectangle here in the red color shows the universe, which is S, and this is a set inside the universe, this circle A, then everything outside this set A but inside the universe is represented by A and a line on top, which is A complement. So I have all elements of set A except the set A represented by A complement. What is U? U means addition of the given set. So A union B union C would mean adding all the elements of the three sets. So I have 1, 2, 3. 2, 3 are here also. We will not write the elements again. So I have 1, 2, 3, 4 and 5. This is the union. Mind you, you will not write the union as 1, 2, 3, then again 2, 3 because they exist in set B also, and then 2 and 5. You leave out the common elements. These elements you leave out. So 1, 2, 3, 4 and 5 represents A union B union C. Let's look at intersection. A intersection B intersection C would mean what? The elements common in all these three sets. Now, as you see, there's only this element 2 which occurs in A as well as B and as well as C. So, A intersection B intersection C is just 2. Now, what would be A union B union C complement? It means that all the elements in the universe, which is S, minus the elements of A union B union C. This is equal to A union B union C complement. Complement is except from this set, you will take all the elements. So, A union B union C, as we found out earlier, is 1, 2, 3, 4, 5. So A union B union C complement is S, the universe, minus all the elements of A union B union C. Let's move on to Venn diagram for two sets. So here I have a set A, I have a set B. This whole combination is A union B. The intersection, that is this region, is A intersection B, and here I have A union B. Sorry for this. I have A union B complement, which means all the elements in this rectangle except from the elements covered by these two circles together. Okay, so let me put symbols on them. Now these red color lines represent the area 3. I'll use a different ink color. Let's take blue. Now only A means the elements only in the set A. These blue colored lines show the elements which are only in set A. These are represented by the symbol 2. Similarly, I have only B. All these elements in these lines, this region, it is represented by the alphabet, by the number 4, and this means only B elements. And then we have finally this outer region, the one marked in green, this outer region which has all the elements except those elements which are already in A union B. So this is the one number here. Let's look at the symbols here. A intersection means both A and B, so it is represented by this region 3 here. So I have written region defining 3. A union B means either A or B, like the element can either be in A or in B. So this is represented by this blue line here, this red lines and this magenta line. So 2 plus 3 plus 4 is A union B, or the elements either in A or B. Now at least one or A union B means the same thing. So this is again 2 plus 3 plus 4. So A union B means either A or B, or at least one of A and B. Now what are the elements in which are at most one, that is which occur in at most one of the sets, not two, at most one of A or B. So either it can be in A or in B, but not in both of them. So which are those regions? I have this 2 which is only A, plus this region 4 which is only B. So I have 2 plus 4. Make sure you have a good visual understanding of sets, because we'll be using these diagrams at a later stage. Neither A nor B, this means nothing but A union B complement, as I mentioned here. So this is represented by the region 1, these outer green lines. Then A intersection B complement means the universal set T here minus A intersection B. The complement of anything is the universal set minus that thing. So the complement of A intersection B is T minus A intersection B. This is equal to A intersection B complement. So what is A intersection B? 3. So everything apart from this region 3 is A intersection B complement. That is why we have 1 plus 2 plus 4. Everything apart from A intersection B. Similarly, A complement would be everything apart the set A. So the set A consists of 2 and 3. So everything apart from 2 and 3 is 1 plus 4. Now these are some of the important formulas which you need to know. The universal set T, n of T is represented as n of A union B plus n of A union B complement. So A union B here is what? 2 plus 3 plus 4 plus the complement of A union B, which is just 1. So 1, we get all these 4 regions, so it becomes the universal set. Similarly, this can also be written as n of T can also be written as simply n of A plus n of A complement. It will get you the same thing, or n of B plus n of B complement. The only thing is that here this and this should be same. I should have a set and its complement. Whenever I add them, I'll get the universal set. Now n of A union B, the number of elements in A union B is equal to n of A, the number of elements here in A, so that is defined by the region 2 plus 3, plus the number of elements in set B, which is defined by 3 plus 4, this 3 here and 4 here, the red and the magenta lines, minus the elements of A intersection B, which is 3. Now why do we have this minus sign here? Because if you see, this 3 was counted twice, in A also and in B also, but for A union B we count the common elements only once. That is why I have a minus A intersection B, or a minus 3 here. So this will give me 2 plus 3 plus 3 plus 4 minus 3, or in other words 2 plus 3 plus 4. This is a very important concept and we'll be using it a lot in the questions to come. Let's move ahead. Let's take an example so that we have more clarity. In a group of 60 people, 27 like cold drinks and 42 like hot drinks, and each person likes at least one of the two drinks. How many people like both tea and coffee? So here I have n of, let's say, C for cold drinks is equal to 27. I have n of H is hot drinks, which is 42, and I have n of C union H is equal to 60. So by this formula which we've just discussed in the previous slide, I have n of C union H is equal to n of C plus n of H minus n of C intersection H. So n of C union H is how much? The total number of people, which are 60. N of C is how much? 27, plus I have n of H, which is 42, minus n of C intersection H. Now this intersection means people who like both the drinks. So n of C intersection H, this is equal to 69 minus 60, or 9. So there are 9 people who like both the two drinks. If I go by the reverse, so now n of C union H is equal to n of C plus n of H minus n of C intersection H. So this is 42 plus 27 minus 9, and this is 60. I hope you are clear with this. Let's move on to the next slide, and we have another question here. In a class of 40 students, 12 enrolled for both English and German, 22 enrolled for German. If the students of the class enrolled for at least one of the two subjects, then how many students enrolled for only English and not German? Let us try this with the help of the Venn diagram. So let's say this is a set E of the students representing who like or who've opted for English. Now I have another set here, and let me write here G representing students who've opted for German. Now what I know is that 12 students enrolled for both English and German. So this intersection region here, this is 12. 22 enrolled for German. So this region plus this region here, x is equal to 22. So x here becomes 10. Now in this circle for German, which represents the students who have opted for German, the total number of students is 10 plus 12, which is 22, which satisfies what is given in the question. Now I am supposed to answer how many students enrolled only for English and not for German. I know that the total number of students of E plus G is 40. So if the total number of students in these two circles is 40 and I already have 22 here, so this remaining would definitely be 18, and this 18 represents only this region here, the one marked in vertical lines, and this represents people who only opted for English and not for German. So what is my answer here? 18, or the C part here. So now we've done two questions, one with the formula and one with the visual representation. Now there are some questions which are easier with the formula and some which are easier with this visual representation. How will you come to know how to solve the question? Is through practice. I've taught you both the approaches. So let's look at the Venn diagram for three sets. We've already done for two sets. This is a set A, this is a set B, and we have a set C. This region here, as mentioned earlier in two sets, is A intersection B. This region, this one here, is A intersection C, and similarly we have B intersection C. We represent A intersection B intersection C by this small region here, which I have marked in red, and then this outer region is complement of A union B union C. Let's give numbers to these regions. So only A would be this element 2 here, the one marked with these horizontal, these diagonal lines. Then we have B, which is only B, which is represented by 3, only C represented by 4. We have A intersection C as these marked in green, which includes 5 and 8. Similarly, A intersection B would be 7 and 8. B intersection C would be 6 and 8. And intersection of all three would be just this element 8 here. Let's look at the questions here. Number of elements which are there in at least one of the sets. So at least one of the set means either in set A or in set B or in set C or in both B and C, in both C and A, in both A and B, or in all the three sets A, B, C. Mind you, here A or B or C means only A, only B, only C. This means only BC, only CA, and only AB, and this means only ABC. So we have all these numbers here: 2 plus 3 plus 4. This represents only A, only B, and only C. 5 represents only AC. 6 represents only BC. 7 represents only AB, and 8 represents only A, B, and C. At most one means either in none of the sets or in at most one of the sets, or that is, or only in A, only in B, and only in C. So 1 represents in none of the sets, 2 represents only A, 3 represents only B, and 4 represents only C. At least 2, it means either in 2 sets or more. So I have either only AB, either or only BC, or only AC, or only A, B, and C. So I have 5 here, which represents only AC, 6 here, which represents only BC, 7 here, which represents only AB, and 8 here, which represents only ABC. At most 2, it means either in none of the sets, or in only one set, or in maximum of 2 sets. You can figure this out. 1 means in none of the sets, 2 means only A, only B, only C. This is only AC, this is only BC, and this is only CA. Neither A nor B nor C. This is nothing but A union B union C complement. So I have T minus A union B union C, which is again just 1, the outermost here, these lines. Then I have, let's say, some symbol like A intersection B intersection C complement. Let's find out what is A intersection B first. I'll take this black ink. So A intersection B is this one. I have the region 7 plus 8. That is A intersection B. Now, what is C complement? C complement is everything except this set A, set C, sorry. This set C, everything except this set C. So everything except 5, 8, 6 and 4. So what are the numbers left? I have 1, 2, 7 and 3. So C complement is 1 plus 2 plus 7, sorry, plus 7 plus 3. Now we have to take an intersection. So the common elements between A intersection B and C complement. So the common, I have 7 and 8 here, and here I have 1, 2, 7 and 3. So the only common element is 7. So my answer is 7. Now A intersection B intersection C complement means everything except, so T minus everything except A intersection B intersection C. Now this is 8. The region defining this is 8. So everything except this region 8. This is what I've mentioned here. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is A intersection B intersection C complement. Let's look at some of the formulas. Again here, n of t, the universe, is given as n of A union B union C, which means all the elements in these 3 circles plus its complement, which will take care of this outer region. So we get the universe. Now this is a very important formula which you need to remember. A union B union C is equal to number of elements of A plus number of elements of B plus number of elements of C minus n of A intersection B minus number of elements of B intersection C minus the number of elements of A intersection B, sorry, A intersection C plus the elements of A intersection B intersection C. Now you can easily form the logic for this. What you need to do is, for n of A, you need to write all the elements for A, which is 2, 7 and 2, 7, 5 and 8. Then for B, you write 3, 7, 8 and 6. Similarly for C. So when you apply this formula, you should be left out only with elements 2, 3, 4, 5, 6, 7 and 8. I leave this to you to try and prove that this formula is correct. I've told you the method. Just write the regions defining A, which is 2, 7, 5 and 8. Similarly for B, and then for all these A intersection B intersection C, B intersection C, and this one. And you should get this as the answer. Let's move ahead. Let's consider this question for more clarity on the concept. In a class of 120 students numbered from 1 to 120, all even numbered students opt for physics, whose numbers are divisible by 5. So let me write number of people opting for physics. That would be equal to 120 by 2, since all even number people choose that. So this is equal to 60. Now the number whose numbers are divisible by 5 opt for chemistry. So number of elements here for chemistry is 120 divided by 5, which is 24. And those whose numbers are divisible by 7 opt for maths. So n for maths here is the quotient when 120 is divided by 7. So when you divide, you'll get this as 17 as the quotient. How many opt for none of these three subjects? So the first thing we'll do here is we'll find out n of p union c union m. So this gives me the number of students who've opted for at least one of the subjects, one or more. So now this is equal to, I'll have n of p plus n of c plus n of m minus n of p intersection c minus n of c intersection m minus n of p intersection m plus n of p intersection c intersection m. This is the formula which we've already done in the previous slide. So I know n of p, that is equal to 60. Then I also know n of c, that is equal to 24. I also know n of m, that is equal to 17. Now what is n of p intersection c? Now p was the number which is divisible by 2 and c was the number divisible by 5. So p intersection c would mean the number divisible by 2 as well as by 5. So I need to have a divisibility by 10 here. So how many students would be there? 120 divided by 10 or 12 students. So P intersection C is 12. So I'll write a minus 12 here. Now I have C intersection M. So C and M here. C was divisible by 5 and M was divisible by 7. So C intersection M would be divisible by 7 into 5, that is both by 7 and 5. So divisibility by 35. So number of elements here would be 120 divided by 35. So the quotient here is going to be 3 because 35 threes are 105. So I have C intersection M here. I'll write a minus 3 here. Now I have to find out P intersection M. So P is divisible by 2 and M is divisible by 7. So I need to have a divisibility by 14 here for P intersection M. So when you divide 120 by 14, the quotient you'll get is 8. So I have a minus 8 here. Then I have to add plus P intersection C intersection M. So P intersection C intersection M would be divisible by 2, divisible by 5 and also divisible by 7. So this means, in other words, divisible by 70. So when I divide 120 by 7, the quotient I'll get is 1. So I'll just add plus 1 here. Now the total number of students you get here is, if you calculate, this would come out to be 79. So the total number of students opting for at least one of the subjects, which is P union C union M, is 79. And the total number of students there in the class are 120. So how many did not opt for any is 120 minus 79, that is equal to 41. So this is your answer. So one thing you've learned here is that if you have, let me just change the color, this symbol here P union C union M also means that the number of students who opt for at least one of the courses. So I have at least one of the courses. So let's look at another example question here. Workers are grouped by their areas of expertise and are placed on at least one team. 20 workers are on the marketing team, 30 are there on the sales team, 40 are there on the vision team. Now let's try this question with the diagram as we did the previous one with the formula. So I have this circle here representing the marketing team. I write a M here. Then I have another circle here. This represents the sales team. And then I have another circle here which represents the vision team. 5 workers are both on the marketing and the sales team. So I have M plus S is equal to 5. 6 workers are both on the sales and vision team. So S plus V is equal to 6. And 9 workers are both on the marketing and vision team. So marketing plus vision is equal to 9. 4 workers are there on all the three teams. So I have M plus S plus V is equal to 4. So one thing which you need to remember here is that you always start with this, the number of people who are there on all the teams, because it makes forming this diagram very easy. So I have marketing plus sale plus vision is equal to 4. So this is the area common to all three circles. So this is equal to 4. Now I have marketing plus sales is equal to 5. So marketing plus sales is this region here. 4 is already written, so I'll just write 1 here. So marketing plus sales, this gives me 5. Now sales plus vision is 6. This is the area common to sales and vision. So I have 4 here. I'll write a 2 here. So this makes it 6. Marketing plus vision is 9. I already have 4. So I will just write 5 here. Now I knew that the people working on marketing team M is equal to 20. So I already have 5 plus 4 plus 1, 9 here. Sorry, 10 here. So people only in the marketing team are just 10. Then let's look at the second figure. I have sales team comprising of 30 people. This is the circle for sales. I have 4 plus 2 6 and 1 7 already here. 30 minus 7 is 23. So there are 23 people working only in the sales team, and 40 are on the vision team. So vision is here. I'll just write vision is equal to 40. I already have 5 plus 4 9 into 11 here. So the number of people working only on this vision team is 29. So what are the total number of people there? You just need to count all these numbers. So this will be 40 plus 10 50 plus 23 73 and 1 74. So there are 74 people working in all in the company. See, it's become very easy once you form this diagram. Let's look at another question on three-way set Venn diagrams. This is a very important question and it will give you a lot of concept clarity. Each of the 59 members in a high school class is required to sign up for a minimum of 1 and a maximum of 3 academic clubs. The 3 clubs to choose from are the poetry club, the history club, and the writing club. So let me assume that this is the poetry club, this is the history club, and this is the writing club. 22 students sign up for poetry, 27 for history, and 28 for this writing club. If 6 students sign up for exactly 2 clubs, how many students sign up for all 3 clubs? So let me write here X, and this is what we need to find out. People who sign up for all 3 clubs. First thing you need to understand here is all the members inside these 3 circles, the count of the members should be equal to 59 because we have 59 members in total. Now if I do P plus H plus W, what does this give me? Let me name the regions here as we did before. This is region number 1, this is 2, and this is 3. Let me name this as 4, 5, and 6, and this region as 7. So the region 7 gives me students who signed up for all the 3 clubs. Similarly, 4 plus 5 plus 6, the region number 4 plus 5 plus 6 give me the number people who have signed up for exactly 2 clubs. So in my figure, these 3 regions represent this number 6, the number of students. So when I do P plus H plus W, what are the regions which define P? They are 1 plus 6 plus 4 plus 7. This is the region P. What are the region that define the circle H here? They are 2 plus 6 plus 7 and plus 5. And if I have to write W, what are the regions that define W? I have 3 plus I have 4 plus 7 and plus 5. If I add all these regions, I will get 1 plus 2 plus 3. They occur only once. 1 plus 2 plus 3. So this gives me students who have signed only for one club. Only for one. It might be anyone. So 1 represents only poetry here, 2 represents only history here, and 3 represents only writing here. Now I have 2 6 here. Now what does 6 represent? People who signed up for poetry as well as for history. So if I add here, I get 2 times 6 plus, similarly I'll have 2 times 4. See, I have a 4 here and a 4 here, and 2 times 5. So 5 here and a 5 here. So in other words, when I'm counting P plus H plus W, I'm counting just once the number of people who've signed for only one club. I'm counting 2 times the number of students who've signed up for exactly 2 clubs. And when you count 7, 7 occurs 3 times. So I have 3 multiplied by 7. So I am counting 3 times the people who've signed for all the 3 clubs. Now for this region to be equal to 59, so 59 is what? 59 is equal to the region 1 plus region 2 plus region 3 plus 4 plus 5 plus 6 plus 7. So every region occurs only once in 59 because it's a union. But when I add P plus H plus W, I am getting 2 times 6 plus 4 plus 5 and 3 times this region 7. So if I have to make it equal to this, I will subtract 1 time this 6 plus 4 plus 5. This is nothing but the people who signed for exactly 2 clubs, and minus 2 times X. X is what? The number of people who signed for 3 clubs. Exactly 3 clubs. So what in other words I can do is P plus H plus W. This is 22 plus 27 plus 28 minus this thing 6 plus 4 plus 5, which is nothing but 6, minus 6 minus 2 times into X is equal to 59. Because now this left side of the equation gives me only 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, all these regions, and the right side also gives me the same thing. So we can just find X from here. So let's calculate this. 22 plus 28 is 50 plus 27 is 77. 77 minus 6 is 71. So 71 minus 59 is equal to 2 times X. So 2 times X, I'm just taking my calculations here. So 2 times X is equal to 12, or X is equal to 6. So the number of students who sign for exactly 3 clubs, the answer is 6. I hope you've got a clarity on these kind of questions. Let's look at this another question here. This is exactly the same as we did in the previous question, but there's a slight change in what the question is asking us. This semester, each of the 90 students in a certain class took at least one course from A, B, and C. If 60 students took A, so I'll write A here and 60. 40 took course B, so I'll write B and 40, and 20 students took C, and 5 took all the three. So 5 is here who took all the three. How many students took exactly two courses? Now again, as in the previous question, A plus B plus C minus once the number of elements, let's say X. Here X represents people who opted for exactly two courses. So in other words, this X is the region here, x1, x2 and x3. So x1 plus x2 plus x3 is equal to x here, this x, and minus 2 times 5. 5 are the people who opted for exactly 3 courses. This is equal to 90, the total number of students. I've applied the exactly same logic which we did in the previous question. So how much is A? A is 60, B is 40 and C is 20, minus X minus 10 is equal to 90. This gives me 120 minus 10 minus X is equal to 90, or 110 minus 90 is equal to X. So X comes out to be 20. So 20 is the number of students who opted for exactly two courses. There are also other ways of solving the same question by using the formula, but this one is the easiest method. Let's solve the same question using another method, having a different approach. So we have 90 students and courses 3, A, B and C. So I'll just write in the information we already know. A is 60, B is 40 and C here is 20. Now we know that n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B plus A intersection C plus B intersection C. This entire thing I'll consider as X, because this gives me the number of students who signed up for two courses or more. Remember this, not two courses, it is two courses or more. Because what is A intersection B? A intersection B is this region. So this gives me people who opted for A, B, this region, plus the people who opted for A, B and C. So this represents two courses or more, and we'll complete the formula plus n of A intersection B intersection C. So this I know is 90 is equal to n of A is 60, n of B is 40, n of C is 20 minus X plus we have 5 as n of A intersection B intersection C. So this gives me 5 here. Let's calculate X. X is 125 minus 90, or this is 35. Now what does this 35 represent is what you need to take care of. This 35 is A intersection B plus B intersection C plus C intersection A. Now when you take A intersection B, you count this smaller region which I am now shading once. Then you count B intersection C, you count this region here, and again this smaller shaded region. And when you count C intersection A, you take this region plus again this smaller shaded region. And this smaller shaded region is nothing but 5 students, which is A intersection B intersection C, or the students who opted for all the three courses. So now we have this sum is equal to 35. This sum has counted this 5 here 3 times. So if I remove this 5 counted 3 times, I'll subtract minus 3 into 5. This gives me 20. This is the same answer as we got before, and this 20 is the sum of the region here, this region here, this region here, and this region here. So this gives me the number of students who've opted for exactly two courses. It might be A and C as represented by this region, it might be B and C as represented by this region, or it might be A and B as represented by this region. So we just leave out this smaller region here. I'm putting a cross here because we subtracted minus 3 into 15. So this is another approach on solving the same question. In a class of 50 students, 20 play hockey. So I'll write an H here and 20. 15 play cricket. So I'll write a C here and 15. And 11 play football. So I have a football F here and an 11. 7 play both hockey and cricket. So I have hockey plus cricket is equal to 7. 4 play cricket and football. So cricket plus football is 4. And 5 play hockey and football. So hockey and football is equal to 5. If 18 students do not play any of these given sports, how many students play exactly two of these sports? So now I have 18 students who do not play any sport. So if I add the number of elements in all these three circles, that should come out to be 50 minus 18 is equal to 32, because 32 is the number of the people who've opted for something, and these sets are for people who've opted playing any sport. So how do we begin? I have H plus C is equal to 7. So this intersection entire here, this is 7. And then I have C plus S, F 4. Sorry, C plus F is this side 4 and H plus F is 5. Now we'll apply the formula. We have H union C union F is equal to, this is equal to 32 as we know. N of H is how much? 20 plus N of C is 15 plus N of F is 11 minus N of H plus C, this is minus 7. Similarly, minus N of C plus F, so I have C plus F is minus 4 minus N of H plus F, this is just the formula we've discussed before, minus 5 plus N of H intersection F intersection C. This plus sign is nothing but the intersection sign, people who play both these sports. So I'll take this figure H intersection F intersection C as X. So I have plus X here. So let's find out X. I have 32 equal to, this is 35 plus 11 is 46, and 46 minus 16 is 30. So 32 is equal to 30 plus X. So X here comes out to be 2. Now this X is people who play all the three sports. So this is 2 here. Now I know that H plus C is 7. So if this is 2, I have a 5 here. H plus F is 5. 2 I already have here. So I have 3 here. And F plus C is 4. I already have 2. So I have a 2 here. This 2 plus 2 will give me a 4. So how many people play exactly two of these three sports? I have 5 plus 3 8 and plus 2 10. Also you can find it out from another method. Once you have that two people play all the three sports, what you can do is you can add all of them. You add all of them, what do you get? 7 plus 4 11 plus 5 16. Now in this 16 you've counted this 2 3 times, because H plus C also has this shaded part counted, C plus F also, and H plus F also. So if you delete these countings of 2 which is done 3 times, you'll do minus 3 times 2 which is 6, and 16 minus 6 is also 10. Just another logic. I hope this is clear. Let's move on to Venn diagram for 4 sets. This is very rarely asked. All you need to do here is memorize how to form a Venn diagram, and rest everything would be given in the question. So you have this set as A, then you have another tower as B. This is how you make a set C. This is how you make a set D. This represents only C. Similarly, this is only B. This is only A. This is only D. And then all these terminologies here, you'll pay some attention and you'll be able to understand them better. But you really don't need to go very deep into 4 set Venn diagrams because they are very rarely asked. What you can do is pause this video for a while, just draw this in your copy, and then you can apply logic and help yourself understand this Venn diagram better. Let's do some practice questions. In the following figure, triangle represents girls, so this represents girls. Square represents players, so this square here represents players, and circle represents a coach. Which part of the diagram represents the girls who are player but not coach? So I want the number which lies inside the triangle, also inside the square but not inside a circle. These kind of questions are generally asked in the examination. So I need a triangle and a square. So I have this triangle and I have this square. So Q plus R are the only two things which lie in a triangle as well as a square. But I do not need a circle, and here R lies in the circle as well. So I'll cancel out R. What is my answer? Q. So this is only visual logic. We'll try more questions on this. Question number 2. Now, triangle represents people taking tea, a circle represents people taking coffee, and this rectangle represents people taking wine. How many people take tea and wine but not coffee? So I need a triangle. The number should be inside a triangle, and wine. So the number should also be inside the rectangle, but not coffee. So the number should not be inside the circle. So let's take the first two case here. How many numbers are there in the triangle as well as the rectangle? I have this triangle and rectangle. I just have these two numbers, 17 and 15. 17 plus 15, which are inside a triangle as well as a rectangle. Now I do not need the number to be inside a circle, but 15 here is inside a circle, so I'll cross out 15. What is my answer? 17. How many people take tea and coffee but not wine? Take tea means I need a triangle. Take coffee, it means I need a circle. Do not take wine, it means not in this rectangle. So I solve the first two conditions first. Triangle and circle, only these two numbers, 15 and 7. 15 plus 7. Not a rectangle, 15 lies in the rectangle as well, so I'll cancel out 15. What is my correct option? Option number B, which is 7. How many people take wine? So wine means everything inside this rectangle, so I'll count the total number. 20 plus 40 60 plus 30 90 plus 15 105 plus 17 122. So this is my correct option. How many people take only coffee? See, in the previous question it was mentioned wine, so I counted all of them. Now I need only coffee. It means that coffee is represented here by a circle. The numbers which lie only in the circle, only in the circle. So in no other figure. I have 20, which is only in the circle, not the triangle or the rectangle, and 25 here. So what is my answer? 20 plus 25. Sorry, only coffee. So I have this 20 and 25 here. So I have 20 plus 25, and the answer is 45. This here. How many people take all three? So it means that the number should be in the triangle, should be in the rectangle, and should also be in the circle. So the only number here is 15, which is the intersection of all three. So what is my answer option here? 15. Let's try some more question. This represents married people. The circle represents people who live in a joint family. So I write a joint here. And this triangle represents school teachers. So ST. By which letter the married teachers who live in a joint family are represented? So it means I need married plus joint family. No, I need married teachers who live a joint family. So I need an intersection of all these three. I didn't read this teachers first. I need married and teachers and joint family. So what is the symbol here which represents all three, which is common to all three? Only the symbol Q. So what is my right answer? Q. We'll change the ink color for the second question. By which letter the married people who live in the joint family but are not school teachers represented? So I need married people, I need the rectangle to be good, then I need live in a joint family. So the number should be inside a circle but not inside a triangle. So let's look at here. I look at the first two conditions first. The alphabets in the rectangle and the circle, they are Q and S. So I have Q and S here, but Q also lies inside the triangle, so I'll cancel out Q. What is my right option? S. You should always follow this approach. Take two at a time and then move on to the third one. By which letter the people who live in a joint family, so I need a circle, but are neither married nor teachers, so only in a joint family, which belong only to this set, joint family. So what is my answer here? T. Because this lies only inside the circle and outside this rectangle and outside this triangle here. So my answer option is the A part here. So let's look at another question here. In the following diagram, rectangle represents men. So this rectangle here represents men. Triangle represents educated. So this triangle here represents educated. Circle represents urban. So this circle is for urban. And square represents government employees. So this is government employees. Which one of the following represents educated men? Educated means I need a triangle. Men means I need the rectangle, but not urban. So I do not need a circle. Nothing is mentioned about the government employees. So we can have government employees and we cannot have them also. Now if you see, I'll take the first two things here. I need a number which is inside the triangle and inside the rectangle. So this is the triangle and this is the rectangle. Only 4 and 11 are two numbers which are inside the rectangle as well as the triangle. But I do not need a circle. 4 is inside the circle also. So what is my correct answer here? 11. Let's look at the second question. Which one of the following represents a woman? Now, if men is represented by the rectangle, what would be men complement? This is nothing but woman. And everything outside the rectangle, it means, is women. Who is urban as well as government employee? So in this question, I do not need a rectangle, so every number outside the rectangle. Who is urban? So I need a tick mark for the circle, and a government employee, I need a tick mark for the square. So I'll first look at these two conditions. What are the numbers which are inside the circle as well as the square? I have 8, I have 10, I have 6, and I have a 12 here. Sorry, 8 and 12 will not figure out because they are not inside the square. So only 10 and 6 figure out. But I do not need a rectangle. This 6 is inside the rectangle also. So what is my answer? 10. The answer option C here. So when you are adding two, take notice that they should be in both of them. Like I committed this mistake of 8 and 12. You should not do that in the question. Do not count 8 and 12 because 8 and 12 is in the circle and the rectangle, not in the circle and the square. Let's move on to the last type of questions. Now these are purely based on logic, expressing relations through Venn diagrams. Which one of the following best depict relation between a woman, mothers and doctors? Now what you need to note here is that women can be mothers, or in other words only women can be mothers. So mothers will always be a subset of women. If you're finding problem solving this, look at the video on syllogism first. So women is a bigger set and mothers is going to be a smaller set. Now doctors can be men, can be women, can be women who are mothers, women plus mothers. So by this condition, what is the best diagram that suits us? This one, because this outer circle would be women, this inner subset would be mothers, and this represents doctors. So men doctors would be somewhere here, men doctors, women doctors are here, women doctors, and women plus mother doctors are this smaller part, subset of women doctors. So this is how you solve these kind of questions. We'll do a couple of more questions. Which of the following best represent the relation between a hospital, a nurse and a patient? So we know that if I have a hospital here, inside the hospital I will have a nurse, and inside the hospital only I'll have a patient, and these two are separate from each other. A nurse cannot be a patient. So what is the best pictorial description? This one here. This outer oval represents the hospital. This could be nurse and this could be the patient. Let's try another one. Which one of the following best depict the relation between a teacher, writer and guitarist? Now there is a possibility that I can have a teacher plus writer. A teacher can be a writer. Also a person might be a writer as well as a guitarist. Also a teacher and a guitarist is a possibility. A person might have all these three qualities also. So what is the best representation? This one. So this one can be a teacher, this is a guitarist, and this is a writer. So I have teacher plus writer, I have teacher plus guitarist here, and guitarist plus writer here, and this forms person who does all three of them. Purely based on your logic and IQ. Let's try the last question for this video lecture. Which one of the following best depicts the relation between a train, bus and a traveler? Now, train and bus are definitely two different things. A train cannot be a bus and a bus cannot be a train. So, there will be no intersection between a train and a bus. Now, a traveler uses both these modes of transportation to travel. So, a traveler will be a bigger circle circumscribing both these smaller circles. So, this is a traveler. So, what is the correct option here? This one. I hope you enjoyed the lecture.